Hi everyone. It has been almost a week since I've seen you or since we've had a chance to talk. I hope you had a chance to look on the Google Classroom and subscribe to it and you're picking one of those assignments. I've really been missing sitting around talking about math with people, and so I wanted to make these videos. I know you can get information in the textbook and from other places, but I just really felt like I needed to teach and I missed you guys. So I'm going to talk about a couple of examples, and they're from the end of that second option, which is really the homework we had started before we left. And the very last part of that was about factoring special products. And so I'm just going to do a couple examples of those and give you some notes on them in case you were confused by it. I will have some videos up shortly, probably tomorrow by the end of the day, for what we're going to be doing the following week. So either maybe I'll have those on Monday, but I'll have some more. Okay, so let me just go ahead and do it. This one is, the first example is called a difference of two squares. Why a difference? Because I'm subtracting. And why squares? Because each of these numbers is a perfect square. 25 and 36. The square root of 25 is 5, and the square root of 36 is 6. And that information is going to be useful. Normally when we factor these, there's usually a middle term. Here there isn't. But it's there, it's just hidden. So the way we could write it is the same thing, 25x squared plus 0x, and then minus 36. Now we do have that middle term, and we can do our diamond problems that we normally do. So I'm going to start with a diamond problem. And I'm going to put, oops, broke my chalk. Put a diamond with a product on the top. I've got to do 25 times negative 36. That comes out to be negative 900. And the sum down here is 0. So I'm looking for two numbers that multiply to give me negative 900, but add to give me 0. Well, if you think about the number 9, that's a perfect square because 3 times 3 is 9. So for 900, couldn't we use 30 times 30? And it's true, 30 times 30 is 900. Why do I care about that? Because if one of those is positive and one of them is negative, I get negative 900. And if I take positive 30 plus negative 30, I get 0. So it's perfect. So I'm going to put those in here, in the diamond. 30, negative 30. After the diamond, we did these boxes. And in the box, in the top left corner of the box, I put my 25x squared. And in the bottom right-hand corner of the box here, I get negative 36. Now, I'm looking to put something here and here. Well, that comes from my diamond, 30x and minus 30x. That way, when I go this direction with the 25 and the negative 30, there's a greatest common factor, and it's going to be 5. So I can use 5x to go here. Going up this way, 30 and 25 again, 5x. Now there is one thing that's going to be different. These were the same, but these are two are going to be a little bit different. Let's think about it. So what number times 5x is 30x? 6. And what number times 5x is negative 30x? So 6 again, but minus. So that's the difference. So negative 6. So does that work? 6 times negative 6 is negative 36. That's perfect. We filled in our square. So our final answer we can write down here is going to be 5x plus 6 multiplied by 5x minus 6. and I've got a difference of two squares being factored to their square roots. That's the pattern, right? 25, the square root of 25 is 5. The square root of 36 is 6. So you could do these problems really fast with all this fancy stuff. Let's do one really quick. What if I had just, I don't know, 9x squared minus 9x squared minus one I didn't use. How about 16? Those are two perfect squares, 9 and 16. And if I use the same pattern, the square root of 9 is 3 instead of 5, and the square root of 16 is 4 instead of 4. I've got my answer. Don't need a diamond. Don't need this box. I'm done. 3x plus 4 times 3x minus 4. That's how you work on the difference of two squares. So that pattern will always hold with the square roots. The next one I wanted to talk about was a perfect square trinomial. This trinomial can be factored like normal, all the same techniques, but your final answer is just one set of parentheses and it's squared. I'll show you how. So I'm starting with d squared minus 10d plus 25. Well, if I do my diamond, I need the product. The product is the first term times the last, so that's 1 times 25. And then the middle term is the sum, negative 10. So I look for two numbers that multiply to give me 25, but add to negative 10. That's going to be negative 5 times negative 5, because they need to add to negative 10, multiply to a positive number. So if you think about this now, the pattern here is that's a perfect square, that 25, and the square root adds to that. So if you multiply the square root times 2, you get that middle term. For my box then, do this quickly. I'm going to put d squared in this corner, 25 in that corner, and then the two things I found from the diamond, negative 5x and another negative 5x. So when I have that, I can go, oh, we're not using an x, are we? We're using a d. Change that. So the variable is d. That was my last mistake of the week. Okay. I'm going to factor out a 5. Nope, I can't factor anything out. When I go this direction, just going to put a d, right? I'm going to put a d here, and going up here, just a d. D times d is d squared. And then what number times d is negative 5d? It's going to be negative 5. Same up here, negative 5. So when I factor this, my final answer comes out to be d minus 5 times d minus 5. Well, those are the same thing. And so you can write that answer instead as d minus 5 squared to the second power. That's our final answer. That's why it's called a perfect square trinomial. And if you look in the book, there's a bunch of other examples like this. They explain more details, probably maybe even more than you wanted to know. But I will give you some more videos in a bit. And until then, do some math, have a good day, and check in with me on Google Classroom if you've got questions.